this question 8 has been the one question that's been asked the most, other than like the heparin protocol for the 240 class. So,
Sure.
so you're not alone.
Okay, great.
I will say that the key is partially wrong. It should be rounded to the nearest 10th. And I think the answer has more than to the nearest 10th. So just something to keep in mind. So,
okay, great.
So there's always a variety of ways to answer these types of questions. And I'll just show you my strategy. Just grab a blank sheet. All right, so it says patients ordered a dopamine infusion to begin at 5 micrograms per kilogram per minute, with the patient weighing 70 kilograms, and the dopamine available is 400 milligrams per 250 ml. So we're going to first and foremost account for the patient's weight. So 70 kilograms times the 5 micrograms per kilogram per minute.
Mm-hmm.
And that'll give us 350 micrograms per minute. Now, when it says, what should the nurse begin the infusion? At what rate should the nurse begin the infusion? When they talk about that, when they talk about rates, if they're not mentioning a drop rate, then they're talking about milliliters per hour. So that's essentially where we're going. We're trying to figure out the milliliters per hour. I'm saying all this just because for me, it helps me to know. It's kind of like, I want to go to Kennywood. I'm just trying to figure out how to get there. And here I want to go to milliliters per hour, and I just need to know how to get there. So I also know, so I have micrograms per minute. So I have time. I need to make that time in hours at some point. And I know that I can convert the quantity, if I can get it to milligrams, to milliliters, because I have what's available there. So there's two things that you need to do with this here. You need to convert micrograms to milligrams, and you need to convert minutes to hours. Okay. So I'm just going to, I'm going to show you the long, or not the long way, but like kind of like, you could do this in 2 steps, or you could just do this in one long dimensional analysis. So I'm just going to show you the dimensional analysis, whether you like that or not. I'm sorry.
All good. Yeah.
But, okay. So all I'm doing here is making some conversions so I can just kind of set this up the right way to make it so I can compare it to what I have available. And the reason I always like to use the dimensional analysis stuff is because I can eliminate units. And then what I'm trying to do is get into milligrams per hour, because I know I can go from milligrams to milliliters. So all I'm going to do is, once I've set that up, I'm just going to take the 350 times 60.
All right, divided by 1,000.
And divided by 1,000. You got it.
Cool.
And you get 21 milligrams per hour. Now that I have the 21 milligrams per hour, now I can relate that to the 400 milligrams in the 250 ml. So I don't want milligrams. I do want milliliters. And then again, before I even do any kind of extra math or anything, I'm going to already be in the right units. Now I just got to plug it into the calculator the right way. So 21 times 250 divided by 400. And that's where you get that 13.125 milliliters per hour. And then I'm going to tell you, I think you should round that to the nearest 10th to 13.1 milliliters per hour.
Right. So it's the nearest 10th when there's like a whole number in the front, and then it's like if it's to the 100th if it's like 0 point whatever, right?
You got it. Yeah.
That's
so
what they're looking for. Okay.
Yeah. So yeah. So if you have like 0.35, you would leave that alone. If you have 1.35, round out the 1.4.
Okay. Cool. Yeah, that makes a lot more sense. I don't even know. I was all over the place with number 8, trying to figure it out on my own. I thought I had it and ended up with 5.3 mils an hour. Like, don't ask me how.
Okay.
But yeah, that makes much more sense.
Okay. A lot of times that happens because there is a either a conversion was either done incorrectly or not done at all. And it's just, and there's so many in here. That's why, I hesitated even just to show this like this, because basically you can do this in 2 steps. You can convert micrograms to milligrams, then convert minutes to hours, and you're still going to come out with 21 milligrams. So, but you didn't freak out, which is good when I set it up like this, because I do have students in the past that have been like, whoa, what are you doing? You can't do more than 1 times.
Right. Now it's just that extra conversion. No, that makes sense.
Exactly. Okay, good. Then I don't need to pull up mine. Or I don't need to put it on the screen here. So let's take a patient, let's say that they weigh, let's just do 195 pounds. So step 1 is I need to convert that weight into kilograms.
All right, hold on. Let me pull up a calculator. I'm doing this on my phone.
Okay.
$195, 2.2. We're at 88.6 kilograms.
Got it. All right. So as far as the scenario, we're going to say that this guy, 195 pounds, he's already been on a protocol. They redo his APTT. And the APTT is 28 seconds. Then the questions would be, calculate the new bolus in milliliters, and then calculate the new infusion rate in milliliters per hour. And are you seeing what to do in the protocol?
Yeah, I'm just reading over again. So I know for
Okay.
so it would be number 11, right? Less than 35 seconds.
You got it. Yeah,
So
step
80
11
units per kilogram.
Perfect. Yep.
So $80 units per kilogram. I'm getting 7,088.
I'm just confirming, so because this is new for me as well, so I don't have it memorized like I do the other one. So good. That's the same thing I got, 7,088. Then we want to convert the units to milliliters.
Okay, this is where I'm getting stuck.
Okay. So you're looking for what you have available.
Is this at number 2, the 1,000 units per milliliter?
You got it. Yep.
Okay, so divide by 1,000.
Perfect.
So 7.1.
All right. The next step then is to calculate the new infusion rate.
So we'll take 88.6 kilograms. 4 units per kilogram per hour.
So remember, it says to increase it by 4. So what are we increasing by 4?
I don't know. Is it? I don't know.
Okay. So look at the beginning of the question where it says to bolus the patient with heparin 80 units, or look at step 10 in the protocol. And see where it says.
Yeah, 80 units per kilogram.
Right. And then we start a drip at
18.
right. So we started at 18. Now it's telling us to increase by 4. So what would
Gotcha. Okay. So 22.
You got it. The trick to this is just obviously you want to find out where to get the information from in the protocol. So you're doing fine with that. So it's easy when I'm saying all the stuff, but you're doing great.
88.6 times. So 1949.2 units per hour. Okay.
Now I'm looking for milliliters per hour. And I don't want to use the bolus dose.
Don't want to use the bolus dose. I wouldn't be doing 80 units anymore.
Well, we're right, but remember, like in the previous, when we were calculating the bolus dose to get it to milliliters, we use that 1,000 units per milliliter of the bolus dosage strength. So if we're calculating the flow rate, we need to use what they're hooked up to with the IV, so that this is still in the same, still found in step 2 of the protocol, but we don't want to use the bolus dosage strength.
Okay, so it's the 25,000 units.
You got it. And that ratio, just for future reference, because these are always going to be the same, is 1/100. The 250 over 25,000.
Got you. Okay. I don't know why I have to relearn these every semester. You would think it would finally stick.
No, because you don't use it. So why are you gonna, it's just, you just use it when you need it. And so
Right.
it makes perfect sense.
All right, fair enough. Okay, so 1949.2 times 250. 25,000. So I'm getting 19.5.
You got it.
That's milliliters per hour.
So the things that are consistent are, you always multiply by the units per kilogram per hour, but what changes is it 18? Is it 20? Is it 22? Is it 15? Those are kind of like the options you have. And then the bolus is either going to be 80 units per kilogram or it'll be 40 units per kilogram. And then when you multiply the patient's weight by either of those numbers, for the bolus dose, you're always going to divide by 1,000. And then for the calculating the flow rate, you're always going to either just divide by 100 or do the 250 over 25,000. And so when you're doing a bolus, the scenario is the same every single time. And then when you do the flow rate, the scenario is the same, but the numbers might change, right? The patient's weight, and then which of the things we're using, bolus versus the flow rate.
Okay.
Yeah.
Yeah, great. I think that's all I need. I'm just gonna probably spend the afternoon watching some